Welcome to physics class, and today class I am going to derive an important derivation, that is electric field at an axial line due to dipole. First let us learn the definition of dipole. What is dipole? Dipole means two equal and opposite charges separated by a very small distance. I'll repeat once again. Two equal and opposite charges separated by a very small distance is called a dipole. Let us represent the dipole on the board. That is, two charges, one is a negative charge, another one is a positive charge. As here we have two charges, these two charges separated by a very small distance. Take that small distance is 2a, and let us consider a point is O. Okay, this point O is the center of the dipole. Okay, this is a dipole, this is the center of the dipole. If it is 2a, what about the distance from here to here? It is a, and the distance from here to here also a plus a, it is 2a. Okay, now come to axial line. What is axial line? That is very simple. So this line is called the dipole axis. Dipole axis means a line which joins the two charges, or which is drawn from negative charge to positive charge, is called dipole axis. If you extend the dipole axis, or the axis or the line which is along the dipole axis, if any axis is line, that line is called axial line. Okay, on that axial line we are going to find electric field. On that axial line we are going to find electric field. And on this axial line, wherever you want, you consider a point, that point is P. Okay, our job is very simple. We have to find the electric field at point P, which is lie on the axial line. Okay, the distance of that point P from the center of the dipole is R. What is R? R is the distance of the point P from the center of the dipole. Okay, from the center of the dipole. Now at this point P, there are two electric fields. Because why two electric fields means, the electric field always produces due to a charge when charge is at rest. Okay, here how many charges in dipole? Two charges, no? One is negative charge, another one is a positive charge. These two charges definitely produces some electric fields at the point P. Let us draw that electric fields produced by two charges. That is, one electric field is like this, another electric field line is like this. So why the directions are different? Because we know the electric field is a vector quantity. Electric field is vector quantity. The quantity which has both magnitude as well as direction, such a quantity is called vector quantity. So electric field is vector. So therefore you have to show the direction also. So then which one is that indicates a positive electric field due to positive charge, and which one indicates electric field due to negative charge? Means that is very simple. Again, go back to the properties of electric field lines. What is the property of one of the property of electric field line? Means the electric field lines always move away from the positive charge. Electric lines move always away from the positive charge, and electric field lines move towards the negative charge. Yeah, this is one of the important property of electric field lines. So now this is a negative charge, this is a minus q. Therefore, whenever you consider negative charge, the electric field lines towards the negative charge. Definitely this is the electric field due to which charge? Minus charge, negative charge. And what about this? This is the electric field due to positive charge, because this arrow indicates the electric field lines away from the positive charge. So now how many electric field lines, electric fields are at point P there are two electric fields, right? Now come to the dipole moment. So this is very very important. Without that you cannot derive a derivation. So the dipole moment means it is a product of either charge. How many charges? Two charges. No, product of magnitude of either charge. Magnitude means don't consider the sign. Product means into, and the distance between the two. What is the distance? It is 2a. The product of either magnitude of either charge and the small distance is called dipole moment. It is represented as P. P is the dipole moment. So you have to show the dipole moment in this diagram. Yes, I showed here. And that dipole moment always from negative to positive. Remember, don't do mistake here. Always the dipole moment from negative to positive charge. It is P vector. What is a P vector? It is a dipole moment from negative to positive charge. Clear? So now let us derive the derivation. Okay. Now consider first electric field due to negative charge. Electric field due to negative charge is given by E minus Q is equals to 1 divided by 4 pi epsilon naught Q divided by the distance of point P from the negative charge. Where is negative charge in this diagram? Here. At what point we are going to find electric field? Here. You have to consider this distance. Is there any distance from here to here? No, right? So but here we have distance from point P to O. What is the distance from point P to O? It is R. Then again, what is the distance from O to minus Q? It is A. So total distance from here to here is R plus A. You have to add that to whole square. This is the electric field due to negative charge. But again remember, electric field is a vector. See, here I show a vector. Vector means it has both magnitude as well as direction. As this represent magnitude. Yes, of course this is a magnitude. And what about direction? You have to represent direction. The direction is the cap. Cap represent direction. This value represent magnitude. Okay. So whether it is positive P cap or negative P cap means just observe the direction. Says dipole moment is from negative to positive charge, right? Here I showed the direction. What about electric field due to negative charge? This is along negative x-axis. See, this is along negative x-axis. This is along the positive x-axis. Both are in opposite direction now. Therefore, you have to take negative side minus P cap. Understood? Why here minus P cap? Because very simple reason, that is the electric field direction and dipole moment both are in same direction means plus P cap, opposite direction means minus P cap. Now better here itself you multiply the negative side, take the negative side here, minus 1 by 4 pi epsilon naught Q divided by R plus A whole square into P cap. This is the electric field due to negative charge. Any doubts? I think you understood the electric field, expression for electric field due to negative charge. Now come to the electric field due to positive charge. Similarly, the electric field due to positive charge. Again, we know that expression for positive electric field, that is 1 divided by 4 pi epsilon naught charge Q divided by distance square R square or X square. And we know that how to measure the distance, where we are finding electric field at point P. From which charge electric field is produces, due to which charge electric field produces, that is positive charge. The distance from here to here. Do you have any distance in this diagram? I think no, right? So how to find that distance means, so what is the distance from point P to O? It is R. What is the distance from here to here? It is A. From this, if you subtract this, you will get this distance. So how to subtract? It is R minus A whole square. Clear? And sometimes you will write instead of R minus A whole square, sometimes you will write A minus R whole square. Don't write, please don't write that, because here which is a greater, R is greater. This quantity is greater compared to this. So you have to subtract smaller one from the greater one. Okay, clear? So of course electric field is vector quantity and this is the magnitude. What about direction? Direction nothing but okay, p cap. Okay, p cap is the direction of electric field. But here I took positive p plus p cap. Reason? Again come to diagram. So electric field direction is along positive x-axis. Dipole momentum also along same direction. Dipole moment also same direction. Therefore, both the same directions you have to take plus p cap. Clear? Now, how many electric fields? Here we have two. Whenever we have two or more than two electric fields, you have to use superposition principle. What is the superposition principle? That is very simple. Superposition principle says that the total or net electric field, the net or total electric field is equal to vector sum of electric fields due to individual charges. Vector sum of due to individual charges. There are two electric fields. One electric field is due to positive charge, another electric field is due to negative charge. One is due to positive charge, another one is due to negative charge. Okay. Now substitute these two values from here. So therefore that is equals to, what is E plus Q vector? E plus Q vector is 1 divided by 4 pi epsilon naught Q divided by R minus A whole square into P cap. Okay. Then plus E minus Q vector, that is minus 1 divided by 4 pi epsilon naught Q divided by R plus A whole square into P cap. Clear? Now that is equals to, what is the common in these two? Whenever we have two terms or more than two terms, you have to take common. Common means the term which is present in both the terms, the quantity which is present in both the terms. See here 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught you can take common, and one more, that is QQ also common. So therefore Q divided by 4 pi epsilon naught is common. If we take Q divided by 4 pi epsilon naught common, Q divided by 4 pi epsilon naught common, remaining in numerator 1, what is the denominator? R minus A whole square. Okay, then plus into minus is minus. Again, Q divided by 4 pi epsilon naught already taken common, remaining 1 divided by R plus A whole square. Okay, not only Q divided by 4 pi epsilon naught, also there is one more common, that is P cap. I'll write that P cap at last. P cap is also a common. So now take LCM. How to do LCM means, so in bracket terms we have two terms, right? In the two terms you have to multiply the denominators. So what are the denominators in these two? One is R minus A whole square, another one is R plus A whole square. Multiply the denominators. Okay. Yes. Here E vector is equals to Q divided by 4 pi epsilon naught into, okay, multiply the denominators. I am going to multiply, that is R minus A whole square into R plus A whole square. Yes, after that, after multiplying the denominators, just cross multiplication, means R plus A whole square multiply with 1 and R minus A whole square multiply with that one. Okay, so if you multiply, it becomes R plus A whole square. What is the sign between these two? Minus R minus A whole square. Close the bracket. What is the last term? That is P cap. Now that is equals to Q divided by 4 pi epsilon naught is into, this is in the form of A plus B whole square. A plus B whole square form of nothing but it is A square plus B square plus 2AB. 2AB means R square plus A square plus 2RA. Then minus, simplify this within a bracket. This is in the form of A minus B whole square. Instead of A you have R, instead of B you have A. So A minus B whole square form is A square plus B square minus 2AB. A plus B whole square means plus 2RA. A minus B whole square means minus 2RA. Okay. Then close bracket into P cap. Okay. So what about this? So if you have A square into B square, you can write AB whole square, right? Whenever there is a sign into between two terms, at that time you can write a power, whole power as a single power, that is A square into B square as a AB whole square. So therefore it is R minus A into R plus A whole square. Okay. Now that is equals to Q divided by 4 pi epsilon naught. Yes. Write the terms which is present in bracket as it is to RA, but here you multiply negative sign for all the terms. Okay. So minus into plus is minus R square, minus into plus is minus A square, minus into minus is plus 2RA divided by, this is in the form of A plus B into A minus B, or A minus B into A plus B. See, A minus B into A plus B. Okay, we know that A plus B into A minus B is A square minus B square. So A square means that is R square minus B square means A square. Whole power, what is the power here? Square. Then close the bracket and write P cap. Okay. Now here any cancelling terms? Yes, definitely plus R square minus R square gets cancelled, plus A square minus A square gets cancelled, and you cannot cancel these two because signs are same. You have to add plus 2RA plus 2RA, it is 4RA. Okay, therefore electric field E vector is equals to Q divided by 4 pi epsilon naught within a bracket 2RA plus 2RA, it is 4RA divided by R square minus A square whole square. R square minus A square whole square into P cap. Okay. Now, remember the definition of dipole moment. What is a dipole moment? Dipole moment means it is the product of either charge, it is a product of either charge, magnitude of either charge, that is Q. Either charge means any one charge, magnitude means don't take the side, okay, into a small distance between them. What is a small distance? That is 2a. This we call it as dipole moment. So now make use of dipole moment. So 4 can be written as, this 4 can be written as 2 into 2. 4 can be written as 2 into 2. Now this 2 into Q into A. What about this? 2A into Q. 2A into Q, nothing but P vector. Okay. Actually this is in scalar form because we written charge and distance in scalar. Therefore you have to use P. P is the dipole moment. Remaining 2. Okay. Remaining 2 into R. See, remaining 2R. What about 2A into Q? It is P into P cap divided by 4 pi epsilon naught within a bracket in denominator R square minus A square whole square. Next, last step, that is 2 into P cap, nothing but P vector, because we know that a vector nothing but it has both magnitude as well as direction. This is a magnitude of a vector, this is a cap represent direction. Magnitude into direction is a vector. So therefore P into P cap, nothing but P vector divided by 4 pi epsilon naught into R square minus A square whole square. This is the total electric field due to dipole. And there is a small special case, that is if when the distance is very greater than the dipole distance, that is when r is very much greater than a. The point P is not here. Let us assume the point P is somewhere at infinity. Okay. So at the time what happens? R will be very greater compared to the distance of any charge from the dipole, center of the dipole. Whenever R is very much greater than A, you can neglect R, that is A. A is approximately equal to 0 because this is greater, this is very small. Very small means let us assume that approximately equal to 0, approximately equal to 0. Therefore, what happens, this electric field expression E vector is equals to 2 into R P cap P vector divided by 4 pi epsilon naught into r square minus a square. A value is 0, leave it, remaining only r square whole square. Okay, 2 into 2, 2 2s are 4, and here numerator 1 r, denominator 1 r gets cancelled. Finally, E vector is equals to 2 into r already gets cancelled, no, remaining P vector divided by 4 pi epsilon naught into r cube, because 1r gets cancelled. So this is a important facility, how electric field depends on distance.